Here I've read in an image of a monarch butterfly, and I want to segment this image into a few pieces, just enough to separate the background, green scenery, and the orange and black butterfly. To perform k-means segmentation, I'm going to focus on one distinguishing feature, the color of each pixel. I'll need to reshape this image so that I'm feeding in a 2D array to the k-means algorithm. It should be m by 3 in dimension, where m is the number of pixels and 3 is the number of color channels. I'll also convert these values to a float type. This is all done to prepare the data for k-means clustering. OpenCV's k-means function will expect this kind of data. Then, to perform k-means, I just use CV2's k-means function. This takes in our m by 3 array of pixel values that we just created, then a value for k, which I've initially set as 2, then any labels we want, none in this case, then our stop criteria, which I'll have to define, then a number of attempts, and finally how we choose our initial center points, which is randomly. But let's go back to our criteria for a moment. I'm actually going to define this above this function call. The criteria tells this algorithm when to stop. Here I'm making that criteria a value of epsilon or a max number of iterations. The max number of iterations are 10, and epsilon is a value we briefly talked about earlier, where if the clusters move less than this after some iteration, the algorithm stops. It's reached convergence. Now I'm choosing a low value of k at first because it will take a shorter time to process. And a k equal to 2 should produce a binary image of the two most prevalent colors in the image. Then, k-means produces an output that results in the cluster labels, 0 and 1 in this binary case, and the center points. Next, I'll want to display this result. To display the segments, I'll need to convert the data back into an 8-bit image. I'll also reshape this segmented data into the original shape of the image copy. Now I'll be able to plot the segmented image as I would any other image. It takes a short amount of time, and you can see that this image is now broken down into two distinct segments. One cluster is this orange value, and one a sort of dark swampy green background. And I can actually visualize the cluster labels by displaying them one at a time, like a mask. Let's see the label equal to 1. So here we can see that cluster 1 contains the colorful butterfly and flower pixels. This is our orange cluster. I can even go so far as using this information to mask the image at this segment. Here you can see I've blocked out that whole segment. But let's go back to our k-means step up here. And instead of having a k equal to 2, let's up this k to 6 and run it again. This took longer to process, but now you can see 6 distinct color segments. There's a brighter orange for the butterfly's wings, and colors for the flowers and different green background. And I can do anything I want with each of these segments, like masking or performing some analysis just on the wings of the butterfly or background. So segmentation can be a powerful tool.